The only homework we had last night was a worksheet on velocity time graphs. You guys remember that just like position time graphs, when you find something on a velocity time graph, it usually leads to something else. For position time graphs, it was first get the position by going up and over, then it was get the displacement by subtracting positions, and then it was get the average velocity by dividing the displacement by the time. Okay? When we're talking about velocity time graphs, same kind of deal, right? You get the velocity by going up and over. You get the change in velocity by subtracting those. You get the acceleration by dividing the change in velocity by the time. And then the displacement, that's the only other real tricky thing here, because it doesn't really flow from the other ones. You got to find the area between the x-axis and the line to get the displacement. This is question number 1 for the worksheet up right now. Can you have a peek at that and make sure that you get all those answers? If you don't, then please ask me a question about one of them, okay? The one that I want to focus on here, unless you guys ask me for something else, is question D. Okay, we want to find the displacement of the object there. Here's what a lot of people will do in a question like this when they want to find the displacement of this. Okay, they remember, hey, I got to find the area. Great, good. Remember, you got to find the area. But a lot of people will find the area of section 1 here, which is the triangle portion of this, and then they'll just ignore this part down here. You can't. Both of them matter. Every bit of the area matters. So I've got that labeled there. 1/2 base times height is the triangle, section 1. Base times height is the rectangle below it, section 2. The answer is not 27. Okay, the answer is 36, the sum of both of those. So don't forget to include everything when you're finding the displacement. Any questions about any of the rest of the parts of it there, A, B, or C? All right, let's take a look at the second one now. This, in a sense, more straightforward because it's one straight line and it starts at something, goes directly down to 0, whereas the last question, gentlemen, started at an initial value. So when we want to find the displacement, we've only got one shape here. It's a triangle. Velocity, okay, up and over. Change in velocity, find 2 velocities and subtract them. The acceleration is just the change in velocity over time. The displacement, triangle is 1/2 base times height. Yep. Okay, don't ask it right now then. Okay. A little bit later on you can ask it. Let's take a look at the third one here. Tougher one, probably the toughest one yet. We got to recognize here, of course, we get 2 shapes when we're finding the displacement. The rest of the questions, they work the same, right? The velocity at 12 seconds, up and over. The acceleration between 0 and 8, well, we're going to go final minus initial. Okay. Divided by time. Between 8 and 18, hey, between 8 and 18 seconds here. This one, we could say, look, A is equal to delta V over delta T, and delta V is 0. Right? Delta V is 0 because it's the same velocity the whole time, right? Delta T is, 10 seconds? It doesn't really matter what delta T is. 0 divided by anything is 0. The other thing you can do for question C is just look at it and say, well, hey, the velocity isn't changing. The acceleration's got to be 0 without a calculation. And then in question D, we've got a triangle and a rectangle again. Okay, let's get the area of both of them, 70 meters. Finally, the last question. Acceleration between 0 and 25. Delta V over delta T. Right? That comes from the first 2 things that we learned, right? Get velocity, get change in velocity, then get acceleration. Velocity up and over, okay, subtract 2 of them, and then divide it by the time, and this is what we end up with, 3.2. I've said here it's slope, okay, but isn't this slope the same thing as delta V over delta T? VF minus VI over TF minus TI? Same deal for question B, except here it's a negative value, right? Because delta V is a negative value, right? 0 minus 80. Final velocity is 0. The initial velocity is 80. Or the rise, or fall, as it may be, 0 minus 80. 45 minus 25 gives you negative 4. That's important, by the way. You have a quiz on this sometime? Soon? Then that negative is important if you miss that negative. Okay? Got it? Any questions about that?